everyone, welcome to Master's class. In today's video, we're going to be talking about bonding. So before I start explaining bonding, there's some basic ideas we need to go over. Firstly is, why do atoms bond? So atoms bond in order to achieve the noble gas configuration, which is a full outer shell of electrons. They do that because they want to achieve stability. But how can they get a full outer shell of electrons? Well, what they do is that they lose, they gain, or share their valence electrons. You might be wondering, what's valence electron? Well, valence electrons are actually the electrons in the outermost shell, or the highest energy level of the atom. Next thing we're going to discuss is intermolecular forces versus intermolecular. So intermolecular forces are actually the forces between the atoms within the molecule. So if we look at these molecules, so it's actually the bond that's linking the two atoms together. Whereas intermolecular forces, or what we call IMF, are the forces between the molecules themselves. So it's the force that attracts the molecules to each other. In this video, I'm going to be discussing the intramolecular forces, or the different types of bonding, which are first the ionic bond, second the covalent bond, and finally the metallic bond. We also need to understand the concept of electronegativity in order to understand the concept of bonding. So electronegativity is actually the ability of an atom to attract a shared pair of electrons. So it's basically how strong the atom is in attracting electrons towards it. Fluorine is actually the most electronegative atom in the periodic table, with a value of 4.0. If we look at the periodic table, the trend in electronegativity increases as we go up and to the right, or towards fluorine. And the reason for that is that as we go across a period, the atomic radius decreases, so the atom becomes smaller, hence the nucleus can better attract the electrons around it. Whereas going up a group, the shielding decreases, so there's less repulsion by electrons, and the atom can better attract electrons. Now we're going to start discussing the first type of bonding, which is the ionic bond. The ionic bond usually involves the bonding between a metal with a non-metal. It involves a transfer of electrons. So in an ionic bond, electrons are lost and gained. If we look at this small video, you can see that sodium donated its electron to fluorine, forming two oppositely charged ions. So in fact, what happens is usually the metals will react by losing an electron to form a positive cation, whereas the non-metal will react by gaining that electron, forming a negatively charged anion. The electrostatic attraction between the oppositely charged ions that form is what forms the ionic bond. If you want to think of it in terms of electronegativity, fluorine is a lot more electronegative than sodium, so it's much stronger in attracting electrons. So it will take the electron from sodium, forming oppositely charged ions, hence the ionic bond. The electronegativity difference actually should be higher than 1.7 in order to form the ionic bond. Properties of ionic compounds includes that they form lattice structures and are solid at room temperature. They usually have high melting and boiling points, and they conduct electricity only in the molten and aqueous state, not in the solid state. That's because in the solid state, all the ions are fixed in place in their lattice structure and they cannot move and carry an electric current. Whereas in the molten or aqueous state, their ions are free to move around and conduct an electric current. Some examples of ionic compounds in our everyday life include sodium chloride, which is table salt, and sodium fluoride, which is used in toothpastes. Now we're going to move on to the second type of bonding, which is covalent bonds. Covalent bond usually forms between nonmetal with another nonmetal, and it involves the sharing of electrons. So if we look here at one example of a covalent bond, hydrogen chloride. So both are nonmetals, and both require one electron in order to achieve a full outer shell. So what they will do is they will form a shared pair. In this shared pair, each atom contributes one of its valence electrons. This way they will both have one extra electron in their outer shell, or a full outer shell. Ammonia or NH3 is another example of a covalently bonded compound. So covalent bonds fall into two major categories, which is nonpolar covalent. That's when I have an equal sharing of electrons, because the difference in electronegativities is very small, so none of the atoms is strong enough to take the electrons towards it. Very famous examples of nonpolar covalent would be the diatomic molecules, like hydrogen, oxygen, nitrogen. Now, the second type of covalent bonds is the polar covalent. That's when we have non-equal sharing. When there's a difference in electronegativity, the more electronegative atom will attract the electrons to its side, so the electrons will be closer to the more electronegative atom. That happens when the difference between 0.4 and 1.7. Properties of covalent compounds include they have a low melting and boiling point, they do not conduct electricity, and they're usually gas and liquid at room temperature. So some examples in everyday life include water, which is H2O, and carbon dioxide. One special type of covalent bonds, covalently bonded compounds, is macromolecular structures or network solids. In these structures, all of the atoms are linked together by strong covalent bonds, and it looks like a network, something like this. Some examples include silicon oxides, which are actually like sand, and the carbon allotropes, which are diamond, graphene, and graphite, which is used in pencils. Finally, the last type of bonding we're discussing today is the metallic bond. The metallic bond is in metals, and the way the bonding works is that it consists of a lattice of cations or positively charged metal ions surrounded by delocalized electrons. Delocalized means they can move around freely. The attraction between the electrons and the cations is what forms the metallic bond. The properties of the metals are actually due to their very specific type of bonding. And because of the electrostatic forces of attraction between the cations and the electrons that we discussed, this attraction is so strong and hard to overcome. So this is why metals have very high melting and boiling points and are usually solid at room temperature. And note, mercury is the only liquid metal at room temperature. We use it in thermometers. Properties of metals include that they're malleable or can be hammered into sheets. They're ductile and can be drawn into wires. They are lustrous or shiny, which is why we use them for jewelry and accessories. And finally, they are good conductors of heat and electricity, which is why I use them for cooking utensils and for electric wires and so on. Thank you for listening to this video. I hope you enjoyed it and I hope it was useful. Please follow my webpage, Masses Class, for more information, worksheets, and notes, and feel free to contact me if you have any questions.